start after the break. You will have 30 minutes for presenting. Of course, 20 minutes for presentation and 10 minutes for questions. And then we will go back to Niels about using OBIA. I learned the pronunciation right now, OBIA. OBIA and mission classification for debris detection in CRIPTIC. It will be 15 minutes, 5-0, which again 10 minutes for questions, and then we will have open discussion at 11:20 till 11:12, which is 40 minutes, and then concluding remarks.
Okay, good.
Hello, everybody, again from rainy Oslo. Now I believe most of you back from technical break, and we will continue with Bert. He's going to give us some information about the previous field activity, and he will touch briefly upon the results we have gotten, and also some notions about the future field work plan. Okay, Bert, floor is yours, please.
Thank you. I will try to share my screen.
And I would like you to introduce yourself as well.
Yes. I'll do that as soon as I.
Yeah, if you go to the presentation mode, it will be perfect.
Perfect.
Yes.
Yeah, thank you, Payam. It's great to be part of this project, which just Alexi was explaining. We have already a lot of results, and also the scientific part, presenting at scientific meetings, is a great achievement. My name is Bert van Bavel. I'm a chief scientist at the Norwegian Institute for Water Research, and I'm coordinating at NIVA the work, the plastic litter and microplastic work at NIVA. Where we do a lot of harmonization of methodologies to measure microplastics, but also macroplastics in the environment. Today, I will follow up a little bit on the last workshop and the field work which has been done in a kind of pilot phase of the project, which of course, as we saw today, already has given a lot of scientific and results to be able to inform our society on the problem with marine litter. I will quickly talk you through this from NIVA. and I talked about this before, just a little bit in the break. My colleague David Etzel, who's also part of the meeting, he will visit Azerbaijan in the beginning of August and do some demos on site and demonstrate some instrumentation that we have developed here at NIVA. Janneke Valk Andersen, sorry. You have probably seen at the last workshop where she explained about this deep dive concept to get more information from litter that we are collecting. A little bit on what we have talked about, this litter collection and removal, which is also an important part of it, and the registration that some things were more successful than others, but overall we have been very successful. Now I will introduce a little bit about this near smartphone cameras and scanners and the work we're going to do on site in Azerbaijan. And then, of course, we're also moving into how do we treat all this data which comes out from the project. So we will talk a little bit about what we've done with citizens, students, which are, of course, we're all citizens of our society, and talk a little bit about what our plans are. Of course, this you've seen, and I've stole some pictures of Elner here. Very excited about that. So many students and staff were involved in the field work where we measure. You see here, measuring the size of the different waste. Find a lot of these fishery nets, and that's connecting to the work which we have been discussing before, that Niels has been discussing, the large items that you find, and this is an example of these fishery nets that we found on the beach. Find also smaller parts. Here everybody's studying and taking pictures of different kind of bottles, which we found which were found in quite a large number of items were these plastic bottles. Registering through the app, which we come back to because this was a little bit more problematic, but also very good taking pictures of all the items that were collected. A little bit problems. We were thinking that we should use this app which directly uploads things into the cloud that we could use for studying, and we were using this debris tracker. There were some problems with connectivity to networks, and if you are out in the middle of nowhere, as Elmer put it out, there might be some problems, so we need to work on that. Basically, we could go back to a more simple, even writing things down or counting things on paper. But we are looking into solving the problem with the marine debris tracker, which didn't function optimally here when we were testing this out. A lot of the pictures, I think I studied last night over 300 different items and photographs which were taken for this, and what we explained on the last workshop, this more deep dive, where does all the debris come from, what is the origin, can we say something about origin? And you see here all from packaging material to different fishery nets, fishery stuff that we found, some of the holders for chemicals and paints, for example, but a lot of the items which were found were bottles or bottle caps. And we even here, you can't see it, but could even find the dates when products were made. So that was a very good kind of indication of the litter which is most problematic in the region. And if you quickly went through the data. This is preliminary. I just quickly, just to give you a flavor of what the data can give us. We find almost more than 80% were these drinking bottles, plastic drinking bottles, which were there. We found also some other stuff. This is a little bit different than if I would go out here in the Oslo Fjord, where we find less drinking bottles, and we find a lot more other kind of items that we also saw here. So for example, in Norway, there's not so many of these plastic bottles. They're not 80% of the total. One of the reasons is that we have a PAN system where you get money back for your plastic bottles, so people are more aware of putting the plastic bottles back into the store. Also, we looked at which kind, or registered which kind of plastics there were: soft plastic, rigid plastic, some metal items, and some paper items. And we looked at where the students tried to get a flavor of where the items were coming from, and a large majority of the items which the students could identify were coming from Azerbaijan, but also some more large range items were found from other countries. And one of the surprising things is that the ones that were coming from large outside Azerbaijan often were had an age of over 5 years. We found the whole bunch of different brands, many of which we also know here in Norway, from Coca-Cola, Fanta, Pepsi, to different more locally based bottles that were found in the project. So what are we going to do the next follow-up of this preliminary data set, which I think was quite impressive. I think I was really happy to go through the different photos and see that we really together we did really a good job. One of the things that I'm a little bit worried about, this was a plastic bottle, but if you zoom in a little bit on the right side of the picture, you can see a lot of small debris there. And if you zoom in more, it's getting a little bit out of focus, but there are a lot of small particles, which meso or micro, which are small particles. Now, I am personally a little bit more concerned about these smaller items because they are mistaken by both fish and birds for food. So I think it's important to have focus on this meso and microplastics. In the last workshop, or the first workshop, we've been talking a lot about these scanners and how we can get more information where these fragments, which sometimes are from bottles, but most of the time are from other items, how we can identify them. So I'm not going into the details because we've done that at the first workshop, but to be able to recognize if there are different plastics, if you look at visual RBG, you will be able to distinguish that it's a plastic of a different color. If it's a red or a blue plastics, you will not be able to recognize if it's polyethylene, polypropylene, or PVC. And I think also Emil already touched upon that. How can we see the different polymers and how can we get more information through cameras? And I think, and we found, now this is on a laboratory scale, that this near infrared part of the spectra gives you the information which plastic. The information which plastic it is in the near infrared region. So it would be great to combine this, of course, with near infrared cameras on a drone, and put that into eCognite and work together with Niels on developing this much further. But this is what we do for the small devices that we are developing. These, of course, are not so advanced that you can use them on drones. But there are cameras that you can use on drones. So looking at, we get these spectra, like I explained last time, from the different plastics. We can distinguish the different plastics. These are different plastics which give us, after statistical evaluation of the results, different by principal component analysis, gives us a big difference that we can match that. So we will, when we come to Azerbaijan, or when my colleague David comes to Azerbaijan, we will have two of these scanners that we can use on site if the networks work. Otherwise, we have to find another solution, and we can distinguish the different polymers from, if it's PET, mostly from the bottles, if it's polycarbonate, if it's PVC, if it's polypropylene, or if it's polystyrene. We can distinguish those plastics from each other, and we can think about different uses and different sources from those plastics. Now, because we had some problems with the network, we decided to also take with us this small camera device. It looks like a webcam, but it's a very advanced and very expensive webcam, where we can take very exact spectra again in this near region. This instrument is even more advanced. It's more advanced than the smartphone scanner, and it can be connected directly to our PC, so we are not depending on a network. So we will try one of these devices on site on the beach, that we can directly see which kind of polymers the different products. And this is not important maybe for a plastic bottle or a plastic bag, but if you get fragments or if you get unknown pieces of plastics, that we can see where they come from. We do that with principal component. This is the models that we are using, and we can store them on our computer. So we are independent from an operating network if we're out in the field. We do this for, these are the sizes, and what's interesting, you can do it for large items, and you can do it for very small items. It works until about 1 millimeter kind of items. And I am very interested to see if we do some beach or sand or a river bench, and we receive some of the sand and see if we can find these small particles, which is degradation. And it's very interesting to see the difference between the Caspian Sea and the Atlantic, where we get Atlantic beaches, which we get from Norway. Yeah, and we will, if we know the polymer, we can relate it to some kind of, roughly to a kind of usage of the different plastics. So the future work is that my colleague David will visit Azerbaijan in the beginning of the first week of August. We will do on-site work with the two devices that I described, and we're going to see how we can get a better registration of the beach cleaning on going back to paper and pencil, or if we can have another solution by an app which doesn't have to connect directly to different networks. So quickly running through the results, which we are already very satisfied, and it's great work that we've done together. I'm really happy about the results and some of the things that we plan to do in this the 2022 season field work. Thank you. Let me know if you have any questions.
I have a question, if possible.
Yes.
It's just to understand these cameras. As I said, we had last year several problems with the networking with the application.
Yes.
It was really strange. Several phones work very good. In several it doesn't work at all. So how this camera will helpful? I mean, with one camera we will scan all. I mean, as I understand, it's not for bottles. It's for other kind of the plastics. But if we will be 50-60% in the field, how this camera? I mean, it will take a lot of time to scan, or how? Can you just a little bit explain it?
Yes. The idea was, the original idea was to have, to have two of these scanners which everybody could use. That would be Plan B is to use the camera. It will only take maybe 30 seconds to scan and get the polymer item. So it is very quick. So I think we need to set up, because if we know it's a plastic bottle, we don't have to scan. If we know it's a plastic bag, we don't have to scan. But if we're unsure about a fragment or a piece of plastics, or then I think we should go to a station where we just check the polymer composition. I think we need to carefully plan that, definitely. This is a little bit plan B, because I'm worried about, because the smartphone scanners need at least 4G connection to be able to match the spectra that the camera will give, match that with the cloud that we have over 500 different consumer items. So that's my big worry. So that's plan B, is we set up a station where we will do the scanning thing of the items that we cannot identify as forms.
I think, sorry guys, for a second question. It's not a question actually, it's just a comment. I think this year in the field visit we will make a group consistent of 3 persons in case of if there's something problems with the applications because of there is no signal.
Okay.
To record maybe manually only, but by other maybe application the coordinates. Otherwise, we have a risk to lose very valuable information.
Yes.
So okay, I see
But
Emil, but
Eleanor, we can discuss this later on in a specific meeting for that. But as Bart mentioned, it's quite important to understand the or detect the polymer for small items, not large items, and it can be done on field or later on. It is possible to do it.
yes,
Bart?
yes.
I think also we should, and that's because that's my interest, my research interest. I think we should do the big litter items, but also filter some sand, and we will give you a protocol for that.
That's another important thing, Bart. Yeah.
And that you can take back to a venue where you will do that afterwards.
Yeah, it
that
can
will
be
a small number, a small part.
It can be done on the lab. But on the other hand, it's important to know the large liters box as well, the polymer of box, because this fragments, you need to identify the source of this fragments. They are coming from bottles or other sort of plastics that the fragmentation happens for them faster. For example, fishing gears or other sort of plastics, or the source is the bottle. I see Emil. Please, Emil.
Thank you. Thank you very much, Professor Payman. Thank you very much, Professor Bert. That was excellent presentation. Yeah, I last time I was visiting with Elmer, actually, the same visit, and we actually used this small software installed on the app on the phone, right? As far as I understood, right, it's also recording the GPS coordinates from the phone. So let's think about the technical constraints, right? If you talk about the mobile phone, right, and it depends on the type of the mobile phone, right? Your precision will vary. I was checking that from geodesy point of view many times. Will vary from 3 meters to 10 meters, depending on the environmental conditions on the phone device, right? It's okay. We can go and measure that and collect the data using the phone. Then we come to the office and we start overlaying over the drone images. If it was the medium resolution satellite images or low resolution, that would be not a problem because the pixel size would allow us, right? But if you come to the office and see all the points are displaced up to like 10 meters, then in terms of the remote sensing analytics, that's gonna be a huge failure. Sorry, please don't accept it as a critical, right? This is one thing. So I would just in this case recommend to think about the RTK measurements, also parallel RTK real-time kinematic measurements to get at least the precision up to 10 centimeters, right? Just to tie to the real nearby station. And the second issue that you already mentioned, this is a technical constraint because I'm really concerned that many people will go and work and then you bring back and in terms of geodesy, it's going to be displaced. So you don't really match to the real location of the plastic. And the second issue that you pointed out as regarding my first question regarding the spectra matching, right? The spectra matching, your tool is giving a very nice spectra matching. But if the source data doesn't have a spectra like range, there is nothing to match, right? So basically, as far as I understand so far, the spectral characteristics are collected not for the remote sensing analytics, but they're collected for the kind of quantitative statistics of general spectral separation and spatial distribution of different plastics. So it's not for the perspectives of the remote sensing. It's better to clarify that in advance so that people don't expect a different thing. But excellent presentation. Thank you so much, Professor Bert. Thank you very much for that.
Yeah. A comment on that. I think you're right, but I think it will help with the ground truthing, and I also agree that we might, if and that in connection with the models that Payam is going to develop, to see which kind of accuracy we need to be able to model. And I think, yeah, that's one of the things we might look a little bit closer in. I don't think that we will solve that in August when we are there. We just need to see what the devices gives us for data and then see how we can improve that if we can combine the two. I totally agree that we need to look at accuracy, but also I think we need to look at ground truthing, and this will give you a stronger ground truthing than just the size of objects that has been discussed. You will know if it's a plastic or not. Otherwise, you still you only decide that on shape. So it's another variable that we can add into the ground truthing of both satellite and drone imaging in data. But yeah, this is a process in movement. I think my first priority is to get the scanners working, to get this extra information, and to look on the smaller size particles when we are visiting in August.
Very good, Bert. Jannike is she's raising hand, and please, Jannike.
Yeah, I was wondering about why the debris tracker didn't work offline, because according to their instructions, if you download the app and the list before you go into the field, it should be independent on the availability of network.
Okay, understood, Jannike. Yeah, understood the question. I think Elnur will answer this question, but as far as I remember, it has something to do with the type of cell phone and things like that. Some cell phones actually, because people bring their own cell phone, most probably some of them can download this, some of them cannot download it on their cell phone. It was one of the source of problem. I think Elnor has more explanation on that.
Well, that was really strange. We downloaded all the application to the phones, and when we were in the field, the problematic was that we have no network. I mean, none of the phones had a network, and the only solution which we used, we have just a few phones which has a little bit network. Emil remembers the situation, and I shared my internet with the other people, and with that it seriously killed my phone. But anyway, we were able to record something, and I'm now really thinking that maybe find some kind of transmitter or something else to increase the signal, or otherwise find good phones. I'm not going to announce a company, but only iPhones work there. So
okay, it has something to do with the phone type as well. Jannike, please.
Yeah, did you also download the lists that you were going to use before going into the field? Because you need to download both the app and the list that you're going to use.
We follow all the instructions which were given to us. We downloaded everything, but that was nothing. The problematic was that, yeah, please continue.
Yeah, and did you contact the marine debris tracker team to ask if they had a solution, or if they understood your?
I write once or twice, but if even they try to do something that will be useless because we already was in the field, because in a city when we try it, it worked perfectly. Nobody expected such kind of problem. So when we were in the field, we found this problem. If even we asked them for the solution, I asked them about the solution. I remember I talked with the Pegam about the situation, but I don't remember they reply me. but if even they reply, that will not help us because of fieldwork was done and nothing could be changed.
No, I was
But
in the
okay.
CC of the email, Elnor, and we didn't get any reply from them, at least as far as I
Mhm.
remember. Or it was in junk email or something like that. I didn't see that. But Yannick, situation is this: they download the software, and I believe they follow the instruction because the instruction was very clear in your presentation, first presentation. Video is available. I will talk about that in my briefing
Mhm.
about the BART presentation. They download the list and library, whatever you call it, and in the city when they had the connection, there wasn't any problem because I remember we had some test and demo in the city around Baku. It was perfect, but in the field it didn't work. However, it worked for some people like Elnur,
Mm.
who had iPhone. They managed to register, but the other phones actually was not successful, and that was the case that I personally concluded that most probably the type of cell phone you use might affect, because some functionalities are not available in some cell phones, and of course we can't urge everybody to bring iPhone. That's one issue. But at the end of the day, this is a tool to register plastic. The online tool, iPhone tool, or even log sheet writing by pencil. This is a tool for. This is not the goal. Our goal is registering plastic. So this time we need to be vigilant and smart. And if I phone or cell phone don't work there, we should write it in Excel sheet or paper or something like that. This is something that we should consider in this field trip.
I
Yeah.
mean,
Just because you should have the form also in Excel format, so you can print it and have as backup. But
Exactly.
another thing, and I was wondering is, did you get any data? Because I haven't gotten any data apart from a little bit of deep dive registrations on bottles. But did you get any data on from the debris tracker information? Because we want to use that to see if there's any other categories that we should include in the deep dive. Because remember, the deep dive is where you should identify problems that needs more information than you can get from the debris tracker in order to identify the sources and behaviors behind littering.
Okay,
So,
Yannick, it is a very interesting question about the data from the application, and I think Elnur needs to think about that because now we are at the end of BART session, and we can bring it up in the discussion session. So Elnur, think about that and just try to fresh your memory about that, and if it is possible to share it with Yannicka and see how we can handle it. So as usual, I try to brief what Bart said. Of course, so many things, but from my perspective, Bart already mentioned about the first workshop and the training we provide in the first workshop, and also mentioned the presentation by Yannick. For whom are interested, the video of first workshop is available on Akvaplan-niva website. So I recommend participants who are interested to go there and watch that
video.
workshop and video. So another important thing that Bart mentioned was the large quantity of bottle actually we found there, and it is another important thing that it shows that we have different region, we have different plastic problem. So you can't really adopt what protocols you have in Norway to Azerbaijan without actually changing the protocol or modifying the protocols, and that's another important actually information we actually got in the CRIPTIC project. Another important thing Bart mentioned was the bottles from other countries. especially from Iran, and he mentioned that these bottles were old. That's very interesting because it shows that because if we consider the counterclockwise circulation of the Caspian Sea, which is well known, it is rim circulation counterclockwise. There is no possibility that bottles goes from Iran to the location we actually studied in clockwise manner. So they need to turn over around the Caspian Sea to reach there. And that's another interesting point from modeling perspective, which is important. He also mentioned this meso and micro particles, which I think is quite important to touch upon, maybe not in this project because CRIPTIC, we devoted CRIPTIC to macroplastic, not microplastic, but mesoplastic, and using this micronear technology to see what's the source of meso or micro particles are quite important. So by this, I would like to close Barton's session, and we will go back to Niels again with the presentation on using OBI and machine classification for debris detection in CRIPTIC. Please, Niels, floor is yours.
Thank you. Quite interesting to listen to your talks here. I think Alexei talked about why. This project is a research project, and I got some question about expensive software, and I agree. So when we discuss why analyze, and in this project is how to detect plastic. Is it possible by remote sensing and drones, and how to do that? And like we said, we were looking for plastic and fishnet and the drones. But then I want to just point out some pricing here because it was mentioned. Yes, I agree. Ecognition is not the cheap software. It's nothing you just purchase and walk around with. It's the professional software. And the main thing with Ecognition is not the cost of the software, but it's a cost of training the person using it and how to use it. I just want to point out the prices. This is our price list we have in Norway from Trimble, and I think it's international. Might be that Azerbaijan have a different pricing. You should ask Trimble for a local reseller and get the price. But these are the prices we use, and we use the prices directly from Trimble. For educational use, if you purchase it, full license will be 4,140 euro. The other thing I was not mentioned is you can rent the software for a month old, for 1 month at a time. We have a customer in Trondheim, NTNU, the university in Trondheim. They purchased one license last year, and this year they have another person working together with the first guy. They wanted the license for 3 months, so they rented one version for 3 months and beside the one they had. So it doesn't. In Norway, these prices are not very high, but in other countries, universities will look different on the pricing. Our oil industry has given us a different view on costs. They realize that. NPOs like Akvaplan-niva will have the prices in the middle there. They have rented the software all the time until now. And I think you can rent the software for approximately 3 years before you have to, would it better to purchase it. And commercial companies, they pay the high price. So this is, I just wanted to point out, but then we have 12 commercial companies who rent out, and I think these rental prices are quite interesting because you get full support and you get the full software. And you can work with for 2 or 3 months, and you don't have to purchase a full license. So I just want to point this out. Yeah, skip that. One of the things we worked on in Azerbaijan, there was a difference in It's different in the beach. This is the beach in Norway, and the beach we have in CRIPTIC project is completely different. And we try to use the same classifiers on both projects. That's quite difficult. And I want to go through some of the problems we have working with your beach. I would rather say you should get yourself another beach that looks better, because it's so everything looks so similar. But anyway, this is a challenge we have, and how do we face that? First of all, when we do segmentation, the polygons must be small enough to find plastic. So when I take an overview of the beach, it's not the whole beach, it's the whole screen becomes blue because there's so many objects. So we're talking about machine learning, which we didn't actually use in the project. I'll show you why. But this is something we tried. This is what you call inland. With the sand, you got some vegetation here is green. So we took some samples here to try out machine learning. Out here, at first thought it was rocks, but then I realized it was some dried out clay, or it was not rocks, it was some dried out clay or sand. And then you have the water out here. And the water is shallow, so through the water you can see the sand. So when you take samples, here's sand, you get samples from vegetation, you get, here's the water here, and you actually have sand out here. So the water comes in behind the sand. And out here you have this hard rock-like clay. When you classify this, you don't get a very good result. As we mentioned, we have 5 classifiers, and here's what we managed to do with base. Water here, that's okay, and sand out here is okay. I think we got more sand than we thought, but then we got water in here. Why is that? Well, the statistical model from base took the samples out here and looked at the data here. Oh, it looks similar, then it must be water. Then we tried KNN. Then we got these clay. Okay, we've got clay all over here. Well, the same samples, the same data sets, the same layers we used, RGB, they all turn out to give different results for the different statistical methods. KNN means a K nearest neighbor, and K is 1 here. Then we have random forest. It looks a little slightly better, but still we got this hard clay here. And I think that's because we got a lot of different rocks and stones in here, but still we got water in here. And the only thing that works well for most classifiers is the vegetation comes out quite well. The water comes out here quite well, and then the sand. So not too bad. And we have ways to actually modify this water here, so the end result would be better. But this is how the statistical model did it. And then we have a statistical model called support vector machine. I mean, look at the previous one, random forest, and support vector machine. They use the same samples. The result is completely different, and they got vegetation all over. And this is support vector machine is assumed to be the best one. So when you work with these things, it's important to know what you're dealing with. Then we did something. I'm going to show you these data later when I show you e-cognition. But we created some different presentation of the data. We got RGB, that was the default value. But then you can create hue, saturation, and value from that. It's also possible to do PCI, and we can also do some filtering techniques to get green, red vegetation index and things like that. And when we use these different layers, all of a sudden the results became much better than using RGB. Still here we got this decision tree. We still got some this hard clay in here, but looks much better. This is not using RGB, it's using these layers that derivated from the RGB. So, yeah, right. I just wanted to point out that okay, I'm gonna do some really dangerous stuff. I'm gonna show you some online demo, real demo. Of course, I prepared it. What you see here, to the left here, you will see all the layers that we're using, the 3 colors, because the computer has got 3 colors. You got red, green, and blue. So in the red, green, and blue, we can place different layers we have. I can press the plus sign here. Then I show variation on different things. For the computer, that's okay, because it does. Remember how I showed you what the raster layer is? Is not takes time. This is the CRIPTIC project is a large project. So you see here, we can manipulate the data so you see how it is. When you go for these other data that are not what we see, it's better to do different. This is a normalized soil index, which is actually the soil. But here we have almost only soil, so everything becomes white. So if I go to the different way of showing data, this is you. Let's zoom in. You got a car down here someplace. Oh, there's a car and some people outside the car. So this is created from RGB. You should ask your professor how to do this. And in cognition, I just go with these are the rule set I'm running, and I have a special place where I create initial layers. So creating these hue, saturation, and value is just a command for me here. And saturation, and then we get value. Value is more like brightness. And here you can see the car. So we play around with these channels, and then we have some filtering index. When we do something called index layer calculations, we got many indexes you can create. Green, red vegetation index, explained on Wikipedia, but it actually shows red versus green. Many of you probably know the NDVI. So green, red vegetation is similar to the NDVI. So we can create this automatically, and that's what I've done. I'm not doing it online because it takes such a long time to process this huge image. So let's have a look on the green, red. So why do we use this green, red vegetation index? Come on. I thought I had a strong computer. Why the computer is trying to keep up with me? I can explain to you why we're using it. When we're looking at the plastic and things on the ground, very often it's not the actual value of the color that's important, but the relation between colors. So sometimes it's red versus green, or red versus blue that we need. So let's go for minus. So well, could be done a little better, but by using these layers, we can actually get some more information from what differs some type of plastic from each other. And this is something we actually, oops. Well, you play around with these things, and the key thing is you need to find some layers that actually can be useful in presentation of the data I want to look for. The reason why I zoom in here is because I zoom in close enough. Here's a huge pile of fishnet. I think some of you showed us an image how you clean that away. But there's another one in here, some green bottles and stuff like that. The question, can we, there's something red too. Something green there. But what about this green here? Here's a problem. We got some green brushes here, and we got the green plastic here. What we found when we worked with this, and this is Frank, actually Frank Boyot, who's I'm sorry he's not with us anymore, but he actually developed a routine where he looked at the variation of green versus blue to actually differentiate green vegetation from green bottles and also the blue thing. So he did some. He was not an expert in this, but he had a very good brain and for finding solutions to stuff. So we worked on this. How should we go about this? We tried machine learning where we actually picked some samples, but there are not enough samples. We got some 3 or 4 bottles you can see here, but maybe we'd need 50 bottles of green and 50 bottles of blue, and then if we used that strategy, we would have manually mapped the whole beach. And then how could we test it? Because we mapped all the bottles. So that was not a good strategy. And very often you come to a place where you don't have all these things. And images, it turned out the images we use here have a different green color on bottles than we have in Norway. Now this is due to the light. How clear is the drone is flying 50 meters. How much moisture do you have in the air? How much dust do you have in the air? There are a lot of things that are different. And also, not to talk about the sun angle. The sun here is going almost straight up, and look down, you have a very bright light. And this bright light is also a problem for analysis because when you zoom out, everything becomes very bright. So there's very little variation in the colors when you look at them. So at the end of the day, we realized we should try to work on each object we want to find and look at the values. I'm not going through the whole story, but let's take Fishnet first. What we found, and this is how the rule set in Ecognition works. You run it. We have created L1. Let's go back and look at L1 here. These are the polygons that are created by Ecognition. If you zoom in, we can probably see some. Yeah, you can actually see the bottle here become one object. So what we found that by changing the scale factor, we get objects with the size of the small object we want to find, and they're not divided into several objects, except for you look at the Fishnet, sorry, you see more or less it became one object, but inside you have some smaller parts. So other places where there's more dirt in it, you get more objects. But this is an extremely important part of eConditions is segmentation rule, because inside here we will have a green color that is typical for Fishnet. If you look at this red object here, I found it perfectly, and this bottle. So now we have the object we want to look for. We can look at the values that classify each object. So when you classify, we're looking, there's not going deep into this, but we have a level 1, which is our objects, we have plastic objects, and we're looking for everything that's unclassified. And the condition. Right. Then we have our green, blue, red vegetation index. That's an index we create ourselves. Where we combine green, blue, and red to see how this. And these indexes go from -1 to +1. So we said, if this is over than plus, 34, it is probably Fishnet. Then we have these normalized soil index. It should be less than -0.01. Green and the green red vegetation index should be larger than 0.051. And then brightness should be over 130. All these conditions must be true. And then we say this object is a Fishnet. Then we add something else. You can do this several times, and you vary these object where you include more, and here you see some special things. We say relation border to Fishnet is larger than 0. Okay, how is that? Because these values are less than Fishnet. That was because on the Fishnet we had some object beside, just close to it, or inside it. They are Fishnet, but they would not be classified as Fishnet unless they have a border to Fishnet. It means that it could be under some mud because the mud changes the colors, etc., etc. So what we do then, I'm not explaining what I'm doing, and maybe we should look at the result. The result here was quite good. The Fishnet there, and of course some of the plastic, green plastic, comes out as Fishnet. We could look at the shape, but well, who cares? When this one, not quite sure. If you looked on the image, just kind of, this might have missed our view. It shows how clever the software is to detect Fishnet. There are more things up here along the beach. So some of these things are like plastic bottles we could change to later. But most important, I want to be sure that we found the Fishnet that is Fishnet. Yeah, we did that. Again, some of the things Fishnet is, if it's completely muddy and got no green color, we wouldn't find it. But going through, we found a huge amount of Fishnet on this beach. going down. So we're looking at that. We could split the screen, and down there we we only show the object, and kind of difficult to see, but down here we just see the color. And I like these. There's a big fishnet with engine and people beside it. You have to realize that you get some wrong classification, and if it's a car, you don't worry about that. But I'm quite sure this is not a wrong classification. This is quite true. So by going through this, we could actually go through the whole place and have a look. And this black screen is just to be able to be sure that you can see it. It can even be difficult to see stuff. See here, probably a bigger pile of fishnet. Most is so muddy it won't look like could be something else, but there's still some green in here we find. This could probably be refined to be done better. So same way we will go through and find the other vegetation. What you found? No, we didn't care about vegetation here now because that was nothing we were looking for. One thing we found a lot of stuff out in the ocean. We didn't care about that because the water is so green. So everything that's out in the water we don't care about. The only thing we had a major problem with is white plastic. We go down here. You see, we can detect white plastic quite nice. Of course, white plastic and the best pink. But if you go out here, because of this beach, you see here there's some bottles here, and but there's also stones in here. That what is white plastic and what is not the white plastic? That's extremely difficult to tell. So we have to find out where it is, and if there are a lot of white rocks in this area, it's almost impossible to see because if I looked at the values on this object here, you'll find the values here. You see the blue, right? The brightness, which you're mainly looking for. Now, if I look at some other object here, this one, you see the values of this rock. I assume it is a rock and not plastic, but I could be wrong. So you get the same color. So this is could be a challenge, but again, if you look on where do we find this object, then you can tell, and also the size of the object, what is a normal size of a rock here, etc. So that thing we could implement in a software and looking for. But we realize that if you're going to look for these things, you will look here in the area where a lot of garbage and trying to figure out how much we have here. Of course, the software will tell you how many objects you have of different types of for this scene. 530 green plastic and 143 red plastic. So you get calculated these numbers right away. So I think how can we use it? Well, the good thing about the way we ended up is we need a segmentation routine to segment the objects in a decent way. And now you can get segmentation routines on for a much lower cost than eCognition. And then we had the values of each object here, which you could change. So what you need is actually a segmentation routine and a way to estimate the colors, and then you have a solution to find your objects. I assume this can be done in software that costs less than eCognition. It could be implemented for NGOs who want to look for plastic on beaches, which includes segmentation and this classification, which is quite simple. You see Fishnet here. We have the same for pink plastic, where we look at the values here. We're looking mainly at color values. Someplace we do something more, and we have some more advanced routines. But for the basic stuff, if you want to estimate how much plastic there is on the beach, and you have a drone and a laptop or a computer, it should be possible to do this in a simpler way. Not because eCognition is expensive, but it takes time to learn and run it, unless you have someone at university who can run it. So, I think this is what I had to show you, but I think
thank you very much, Niels.
Yeah, I just have a final comment, and that's
Please.
when you see these. That's a problem with drones, and luckily we got a high resolution data and 16-bit data here. But you see, on these beaches, everything is white or whitish, and the colors are very strong. So you need a low resolution and good quality to actually find the objects. Yeah.
Very good. Thank you very much, Niels, for this technical presentation. Very technical presentation. I'm not quite sure I understood the 30% that I understood from your first presentation, but it provides us a good overview of what you are doing and how it can be time consuming and tedious job to actually start from segmentation routine to put the value on different objects and then go to recognition of different items. I see firsthand the Emil, but Emil, before you, Professor Rustam, actually, I asked him to keep his question for Niels' session. So I will give opportunity to Professor Rustam to ask his question, and then I will definitely get back to you. Professor Rustam.
Thank you very much. Excellent management. I have to mention it. You remember everything under your control. Excellent. Niels, my congratulations. Both presentations are very important, very interesting. To be honest, I got huge of interesting things from your presentations. From this point of view, I would like kindly ask you, maybe there is some recommendations can be done by yourself, because in particular for machine learning, data processing time is very important, because for machine learning, there is huge of data needed to be processed. In this case, how we select the appropriate methodology for reducing of data processing time, because in some cases, input data takes a vital, huge of times for data processing, and it takes a vital place how to select for appropriate methodology for reducing of data processing time? Thank you very much.
Very good question, Professor Rustam. Before, if you close your mic, I will be able to talk. Before Niels answering this question, it is something that I was myself thinking about as well. Niels, when you answering question by Professor Rustam, can you comment on that if it is possible to have this e-cognition on like as multiprocessor in parallel system on supercomputer or some systems, some faster systems or more systems with more capacity that you can split jobs to different CPUs and get the like shorter processing time. If it is possible, we should think about that.
Absolutely, that's a good question, and of course we have the solution already. Well, more or less, we have well, Trimble has created what do you call it, Docker? Forget the name. I think call it Docker station. You can upload your data to one of these large providers with supercomputers, where they run the software in the container. And so, especially not the development part, which you would normally use on your laptop or your own computer, but when you have a rule set that works, which I can actually on here just press it. I can just go up on the top here. I can just press on what we call workflow here, and everything will go automatically. It's possible to upload these rule set to a container up on the web, which can process thousands and thousands of images automatically. E-cognition has a server license as well. I didn't put the price on that, but there's a little less than the developer, which you can process automatically. And you can add as many, what do you call it, processors you want. And of course, you pay for the number of processors you get access to. Then you can process and you can take large amount of data much faster. So we have customers with a license for 4 servers, which can run in parallel. One thing I've always been thinking about when you work with large data set is you have to upload them. So you need a good internet connection to upload, let's say, 5 terabytes of data, because that takes time. And when you're done it, you need to download the result. Well, the original images, you don't need that, but you need the result back. So uploading and downloading time is something you need to consider. But the question is very good. And yes, we have the tools. Either you want to run it on the supercomputer at university. They do that in Trondheim, or you can use something from Amazon or Microsoft, some of these large providers. That's also possible.
Thank you, Niels, for answer. Now we go for Emil, but before that, I would like to mention that now we are entering to the discussion session. So all participants are actually can involve in questions, and I encourage them to come back with questions regarding all sessions, not the new session, all session. Yeah, Emil, please.
Yeah, thank you. Thank you so much again, Professor Neil, and a fantastic presentation, and thank you very much. I appreciate that a lot. So basically, the question is, your defined parameters, right, based for your bands, for your band combinations, right? How much are they sensitive to changes in terms if, let's say, Elnur decides to run the drone campaign, not in summer, but he will decide to run the drone campaign in winter. And you will have different soil moisture characteristics and other characteristics of the environment will change. So how much how much it's gonna actually be adjustable, and how much would that take to adjust your model to different seasonal conditions so that this model actually provides the same results like you showed us. Excellent presentation. Thanks again, Professor.
Okay, the answer is short. You need to change it for the light conditions, and we found that we should use the same methodology, but we had to change the values. You're quite correct. You have to change the values. One thing we did not try, well, we used some of these data. We used the relation between colors. And I think if we go more along that road to look at the ratio of color instead of the color itself, we would probably be better off. But again, in this project, I just helped Akvaplan out, and I didn't, for the time being, I didn't have enough time to test out all this. But I agree with you. I think that's something we should look into to get a better result. Now we have the truths from one processing, and if we change the things, we need to try that out, and if we get the same result, and then we need to go to another place. But Fishnet, we found we use the same routine for Fishnet in Norway, and we found them, and I think we changed the values a little bit, especially brightness, because brightness is different from your country and to northern Norway because of the sun angle. So yes. You're quite right. I think it should be possible, but I'm not. I will not guarantee that's possible. But the methodology can be used, but we need to adjust some of the values, which is not a great job.
Yes, I see some hand, but I can't really find who raised this hand. Okay, Sevinch. Am I pronunciation correctly? Yeah, please, Sevinch.
Yes, please.
Thank you very much for a great presentation. So I have a question related to software. You know, there are some free softwares like QGIS, and my question is, for example, in QGIS we have object-based classification like in the tool that you used. So can we use this tool instead of that you used? I mean, would it be precise enough, or it wouldn't be sufficient?
Good question. We need to try this out, and also the speed and stuff like that. I'm ArcGIS has done a lot of enhancement in the software. They used for remote sensing to be slower than eCognition, so it takes longer time. I'm not sure if that's the truth anymore. But if you use the same, I mean, the values we choose and how we use it could be used in other software as well, because that's one of the goal with this project is not to sell recognition. It is actually to find the values we need to classify. So if you should use the same values and if you have the same brilliant segmentation routine, you should be doing okay. Again, scale factor for segmentation is important. You need to find the right object and then the resolution of the images, etc., etc. So, but if they have a good solution for that, our methodology is quite simple. So the answer is probably yes.
Thank you.
Sevinch, did you get your answer?
Yes.
Yeah, still I see your hand is rising. So yeah, if you turn it off, it will be very good. Yeah, Niels, I remember when we got this image, drone image. I tried to open it because I don't have e-cognition, and I tried to open it in Adobe Illustrator, and it took me like several hours to open it. But in your software, you open it in a second. So that's quite important thing. If the software has enough capacity and capability to do that, then values, and you use the same values, so you will get the same result. There's something that I shouldn't ask questions because I'm moderator of this workshop, but there's something in my mind about this machine learning, because you mentioned we dropped machine learning because we didn't have enough object to use. For example, a couple of bottles and things like that. And you mentioned that most probably we need 50 green bottle and 50 red bottle to be able to use machine learning. Am I right? And my understanding was correct?
Yes, and I was when I saw your title of this talk, I said, well, I'm gonna give him the right talk he wants, but that's why I included this in the beginning.
No, just
Yeah.
my understanding is correct. So I was just thinking, I was thinking, is it possible to put some dummy items, for example, to be able to use that dummy item to calibrate and use machine learning? For example, if we can deliver deliberately 50 green bottle and 50 red bottle and 50 white bottle in the area that we will have drone activity, drone imagery in that location, and we mark them and we know that this is our dummy items.
Yeah.
Is this something that can be helpful for future work? Because we will have another field trip in near future.
We discussed that when we started this project to do just that, but then we realized that the object we're looking for have been on the beach maybe half a year or a couple of years, and part of it will be filled with sand and dirt. It will not, if you put clean things on, you will have to put dirt on them, but you won't be able to put growing moss and there's all the things happening to these objects when they lie on the beach. It's very difficult to do that. I think it's better that when we do have a lot of these things, that we can put in some machine learning of some type to do that. But on the other hand, threshold values as we use, it's actually part of machine learning, because we use the software to find what values are correct. So we use actually recognition to find the values we're looking for. It's not guessing. We're actually using the software to find out what values will detect these fishnets. So it's actually part of the tool recognition to find these threshold values. There are so many tools we can't go through all of them now, but they're part of the analysis. So threshold analysis. I mean, it's a good solution and it works. And if we find the things we need, it could work. And
I think bring in some old plastic, because I know this aging process and yellow shift of plastic and all this growing up moss and everything and things like that happens when you leave plastic, and a brand new plastic actually don't reflect the same. Their reflection will be completely different. I was thinking bringing some items from Baku or somewhere that they're already old plastic. Or from the previous field observation when we have old plastic. But this is something we can discuss later. Emil, please.
Yeah, thank you so much again, Professor Payham and Professor Niels. Yeah, I want to actually come up to the same issue, right? What was mentioned by Professor Payham, that was really reasonable, and the issue I actually use this approach, for land use, land cover classifications, and it was taking really lots of time to perform that and to generate billions of segments, right? But the only issue, right, in this case, the topic is very specific, right? We talk about specific plastic objects, right? But ultimately, we are trying to segment something that we don't need. There are some areas which shouldn't be segmented. So ultimately, that's an issue. So now we talk about a small area. If we talk about the entire Caspian Sea coastal zone with such a resolution, it's gonna take several years of processing. Now it's really just a small area that we are talking about. And ultimately, to be optimistic and to reduce again, I'm not trying to change your project strategy or your intentions. You are the leaders of your field and you will decide. But still, to reduce the costs and to make a better better business value, because this project actually doesn't generate additional cost. It's just you are doing a good thing for the environment, right, and society, right? The issue, like, definitely, I would just go and try with the deep learning approach. I would use the TensorFlow, PyTorch aspects, so that to make some coding, right? To make some coding in this case, and this is not something of cost, right? In this case, I go away from the commercial software and I do a coding. And in this case, you will solve several problems. You will use no commercial software. You will solve the issue with the seasonal aspects, but I understand you that there are different shapes which cannot be actually, it's very complicated to actually incorporate so many samples of different shapes. I understand your comment about it. If you have 40, as you mentioned in the beginning, if you have 40 samples, you can do anything. But if you increase this library, you can really get a good solution and more cost effective and reasonable, and useful by everybody, this is just a comment, no strategy like changes, it's just a comment, but I agree completely, right? I really try to kind of make a strategy of sustainability, in this case, and so that everybody can use. But excellent solution what you presented. Thank you so much, Professor Niels and Professor Pegram, once again. Thanks a lot for that.
Thank you, Emil, for your comment. I think Niels is already frozen. Niels, are you there? Okay, he will get back. I think still I don't see any question, and we are in the discussion session. There was some topics that I already noted them down for discussion part. One was data from cell phone, and Eleanor needs to inform us about that. If we manage to download data from cell phone and those small number of cell phones that really worked during the field trip, because we know most of them didn't work, but there was a number of cell phones, they worked, and you managed to actually upload data to this platform. Yannick, are you here still?
Well, at least I will answer to my part, maybe.
Yeah.
Yes, I remember. What I remember from that time, I think some of the members made maybe different kind of registration. And that time, when also we had a lot of results, I mean that results which Bert said, and actually how much we had, it has 5 or 6 times difference what we had on the mobile applications. But unfortunately, we could not download them normally.
Most probably Yannick can help us, and right now I see she raised her hand, but most probably later on she can help us. Yannick, please.
Yeah, because there were some instructions on making sure that you know that you have the data collected, or you're downloading the data that is collected by your team, that you make a project name. So if you have troubles getting hold of the data, then we need to contact the Marine Debris Tracker team and ask them if they can help us. So maybe you can do that. Yeah.
I think we have to start creating this CRIPTIC in the project, in the application right now, because also it's written several days, but normally by different reasons it takes more time. So in many cases we could not get the name of the CRIPTIC in time. So we use just independently. Every person used by its own, like new track without CRIPTIC or something. We selected something different, but anyway, nobody was able to take. We had the results in different phones, but more or less this data was not possible to upload. So I think for not getting the same problem again, not to wait for example, week before of the field visit, it's better if we start now, registering again the cryptic, and if something will happen, react in time. Because that
Yeah.
time when we did, it doesn't help us a lot.
Yeah, I think it's important to always have backup on paper when going into the field.
Yes.
But if there were some registrations, you should be able to find them based on the area they were recorded and the dates.
Yeah, Nico, I remember that there was a registration. Elno registered Cryptic, and he showed me actually at that time. So there should be registration for Cryptic in mobile on mobile application. So the question is that if we can get data from that, or that registration is expired, or something happened, most probably Elno needs to go back and look at that registration again and see if there is a data in that or expired, or what's the problem of that registration.
I just tried to say that, sorry for interrupting that, on a moment when we were in the field, we could not receive from the program developers the name of the cryptic confirmed one. So we used like by default, I mean general independent individual accounts, like each person has its own track, but that was not under cryptic because of we could not receive the registered cryptic name before the event. That was one of the problems. Also, there was a also because of the program started not to work on the way while we were going there, we selected different possibilities while registering. There was different platforms, and then in condition of non-normal connectivity to the internet and other not cryptic name confirmation, finally we get very mixed. I mean, we got the data, but we could not get it because it was registered in spontaneous form. So this time we plan, as I said, start registration to check out if a cryptic is still there or expired. If not, we should register it again, but in case that we still get any problem again, to avoid any problems, we will change the structure of the groups. It will be 3 or 4 person. In case of if program doesn't work, other additional 2 person we will do what the program normally should do by on the paper. This is the only way to avoid it. About protocols, we have it. I sent it, I share it with the colleagues. I hope you also have received it. Protocols are the only thing what we have from the field, what we could catch.
Yeah, but if registrations have been done under different protocols, we could still access that data, because I don't think that there's, yeah, if we just go onto the website of the Marine Debris Tracker and look what has been registered in that region, and then we can look at kind of just making that data comparable across protocols, just for now, to be able to get some insights into what's there, because that information is important in order to understand whether we need to do some changes to the deep dive protocol. And from the presentation we just heard, it seems like fishing nets is quite abundant in some areas, and we might want to try to find out more about that, and make a fishing net protocol.
Well, after the workshop, I will try to connect to my account again. It's still installed to my cell phone, and I think the several people who, I mean, was in the fieldwork also participate in this workshop as well. If this program still in their phones, it's better if they check it, find out if they can get the data, and after that I can tell if we have anything or not, because that moment that was looking that there is no possibility to get them.
Eleanor, I think it sounds like a solution. After this workshop, you can check it out if it is possible to download data or not, because as Yannick mentioned, this is important data. Also,
Yeah.
Bert wrote that he's offline, but they will look at the plan B if this mobile application actually don't work properly. So we need to have a plan B for that. Another subject for discussion was micro-near and positioning, but unfortunately Bert is not here. The question actually, or the discussion raised by Emil about the using micro-near and the position of the particles, and he mentioned that most probably we need DGPS or something like that to position particles properly. Bart tried to answer it a bit, but I was hoping that he's available right now to discuss a little bit more, but he's not. So, but the main actually approach of micro-near will be identifying the polymer. So to understand which sort of polymer is prevailed in that location without looking really into the location, the exact location of the polymer. So this is the main approach of micro-near, rather than identifying polymer and actually pinpointing polymer to exact geographical location. No, it is not the main goal. Another thing that again raised and discussed was about the project cost. I think I stopped Alexei to talk about that, the dimension of project, because he was talking about the training and education, and is costly, and also this is some sort of future asset, because starting a job is costly, but when you train people, when you establish the seed and a point for future work, then everything will be much more reasonable in time. So Alexei, would you like to add something upon that?
Yeah, actually, you told almost everything, and I, which is an associated issue that Yannick mentioned about data that are collected by citizens, so through citizen science, how they can be, because that is also part of education, an important part of education when you train people, because yeah, when you're out in the field, and of course safety is the first priority. But then if you talk with people and educate them and train them how to collect data, then you prepare this data for later on processing and application into, say, scientific environment. And that can be costly in a way, because in general, data, they have value, and this value has a price. And that is a question when you pay and whom. So you can invest into education and then use less money later on for processing, or you can do the other way. And then actually education cannot replace anything, because then you do not waste the data. So that is more about the future, that in the future focus when the project has a good line, when you have a good line on and the logic and algorithm of collecting the data and coming into the product, then you train people on how to get into this process in the very beginning. Because also that is in a way a challenge to Yannick or to everybody, all the scientists who are working with, let's tell citizens or volunteers. Quite often, or that is a general complaint, that we get a lot of data that we can do nothing about, and then we throw them away. And that is kind of complaint to citizens, but that is in reality complaint to us, that we did not put enough forces into getting those data available for ourselves and applicable. And in relation, when we do environmental studies, we cannot have a dialogue with the environment to deliver the data to us in a way we like to have them. Here we have a possibility to have a dialogue with volunteers and students and so on. We should use this possibility from the very beginning. So that is the way to reduce the costs. We reduce them in the very beginning. educating instead of investing too much at the end point. So that is a general approach. Yeah, I know that I'm selling my own work package, but that is what I believe in.
Very
And
good, Alex.
by the way, I'm engineer by education myself, and satellite remote sensing, it was in JS. Introduction to JS, it was the first subject I was teaching in university. It was 25 years ago. I stopped doing that. I stopped doing JS, started to develop much faster than myself. So then I left it.
Very good, Alexei. Thank you. Thank you. I see. Okay, it is always like that, Alexei. So you shouldn't regret. Life is faster than us, and that is a fact.
Yeah, I cannot manage that. I just need to adopt.
I understand.
So
you need to cope with that. So that is a fact. Niels, I see you raise your hand.
Yeah, I'm sorry, we have a thunderstorm going over here, so it took away electricity for a second or two, enough to lose connection. Just a question about when we developed this, it was just to see if we can find the plastic. But what you seem to look for something that could map all the beaches. Yes, I think that's doable. And but then we should develop the methodology a little better, so reduce the area we're looking for. And if you have a good map of the ocean, we can use that to reduce the area, so we don't look into the ocean, etc., etc. So there are many ways we can improve it. But what we looked at is how can we, by drones, find the plastic on the beach. And we discovered that we could use the same methodology as we used in Norway with a completely different beach. So, yeah, but then there were different ways to move forward on this to make it cheaper and faster. So I just want to comment on that.
Thank you. Thank you very much. I don't see any more questions. So then I think we will have Elnor, and we will give floor to Elnor to have concluding remarks from Elnor regarding the project and Azerbaijani partner. I would like him to mention that with what number of the partner we start and when we are at this moment, and also his conclusion about the workshop. Please, Elnor.
Well, thank you again. Thanks. I really appreciate all the participants who had the time to attend our workshop, who has the interest. And I have to say that if compared the last year and this year, the qualitative part of the participants changed incredibly in a positive way. And if last year everybody was interested in sharing the information, now most of them trying to catch the information because of everybody understand that they can learn really valuable things and nobody wants to share it. From one side, it's maybe good, but for us, for spreading the information, maybe not good, but it's good that people understand the value of the work, the quality, and the information what they can get from the our work. Regarding the participants, today we had about 73 participants, and the other about 20%. And also our partners from Akvaplan-niva, they say that apologizes. They were very busy in the field, so they couldn't attend. Regarding the partners, I want to say this one thing. When we started the work, the project, sorry, mostly it was NGOs. There were no partner commercial companies, just only Caspian Geomatics, I think, and Quintessence. Now we have, now we have Esri, now we have BP, now we have Geotech, and now we have Caspian Locus, Asgreen. We have executive power of the Neftchala region. It's very important because of last year's field mission was possible thanks to them. They provide us special equipment as the transportation because normal buses can't go these places. It's God-forgotten places, let's say, in the civilization way, but very attractive for us in our research way. And now, while this workshop was going, as I understand, probably we will have new partners. I can't say their name right now, but as I understand, and what is good, what my own observation in work, private companies seeing that what kind of approaches, what kind of things we want to do, and as Pegam said before, public awareness, like they see that we want to help people, we want to help the government, country in solution of the maybe difficult, maybe the problem which would take for long years. When they see that we have such kind of approach to learn it, study it, and also share the information with the people, they want to be a part of this. Like Geotech, like BP, like many others, they open their possibilities. I mean that support as much as possible to make this work as much as good, because of positive outcome finally cover all of us. And in the same way, we try to answer to the requirements in the forms of the workshops, train as much possible, not only students, but also the experts. I hope everybody was, how to say, satisfied of or what they was expecting from our workshops. But again, if you have remarks or questions, feel free to write to us. Pegam, if I miss something, you can, how to say, correct me. But again, thank you so much. This is what
it was perfect, Elnur. It was perfect conclusion from Azerbaijani side, and I really appreciate that. We need to understand that plastic is an emerging concern. There is no boundaries, there is no limits, there is no border in plastic, and it is an environmental problem that we all face, regardless we're living in Norway, Azerbaijan, or Turkey, or Georgia, or Iran. It doesn't matter really. Plastic is there, and we need to face with that. And actually the soul of CRIPTIC is that, because what we were thinking in CRIPTIC was transferring what we learn in Norwegian environment to the Azerbaijani environment, and also learn from our Azerbaijani partners back to us. It is two-way actually collaboration. It is not one-way collaboration at all. And this workshop actually shows that, because I remember first workshop and second workshop, we got very good question, and people were talking and criticizing, and without criticism, actually you can't develop. So it is exactly two-way collaboration, not one-way collaboration. As Elnur mentioned, we start with very small group. Now we are developing and we are growing. And this is another part of the CRIPTIC soul, because public awareness is the final goal. We start with this understanding, mapping for cleaning. This was understanding to understand the issue properly and then try to find a solution for that, not going to blind solution. And now we are seeing that the public awareness is there and it is growing, and we see more enthusiastic people from university professor at university level to student level. They are encouraged and their enthusiasm to take part. Also, public sector and private sector and industry. We see all of them. And that's another thing that we really appreciate, and we're really thankful, and we are celebrating that in CRIPTIC project, really. By saying that, I would like to give a small overview about this workshop and conclude the workshop. We start this workshop with remote sensing and machine learning and background of that, and what's the scientific background and why we have chosen different approaches. Then we provided some notion about the public awareness and how we develop public awareness in CRIPTIC project. And we see CRIPTIC project as sort of seed or a seed point for marine litter organization, or combating marine litter or marine plastic in Caspian Sea. And then we provided some details of the last field observation, which was quite interesting and quite challenging. And the information we got from them, and we understood what sort of plastic prevailed in that region and what should be our first target. So we don't need to go, for example, old tire or tire microplastic or things like that. We need to battle with fishnets and bottles at this moment to get the plastic actually pollution first stage, to get the first stage in plastic pollution combat. And we end up with some sort of technical presentation of remote sensing and machine learning. Of course, during all this journey, our participants with good questions, good comments, and with their active roles helped us. I would like to thank you again for participating this workshop, and hope see you again in the third workshop. Thank you very much. Have a nice day.
Just one comment.
Thank you. Thanks a
Please,
lot.
we have several participants whose names was not on the mail list. It's good that they participate, but it will be good if they write me an email. For I already registered their name, but again I need the emails to be able then send them their certificates. Thank you again. Bye bye.
Send your names to Elnor for technicalities. Thank you very much. Have a
Okay.
nice day.
Bye bye.
Bye-bye.
Bye bye.